Today we're going to be talking about lifts. To continue our design section.
So just before we go on to lifts, we're just going to go back over the basic types of bases. So, remember square base, U base, and H base, the bases that we normally use. And you guys remember any advantages and disadvantages of these bases?
Square base is usually more stable, right? A U-shaped base is good when you want to like pick something up in the front and you need space for that. H base is kind of a combination of both those things.
Eric, what did you say?
An H base is kind of like a U base, where it has room for stuff on either side, but the disadvantage is that you don't have a lot of surface area to attach those things.
Okay, so let's start with our lift stuff. So these are the general parts that you're going to use for a lift right here. So we got screws, obviously, caps, nuts, nylocks, C-channel, sheet metal, gears, sprockets, motors, just a bit. Is there any parts on here that you guys don't recognize or you want to know more about?
What's a potentiometer?
Potentiometer is a sensor that you put on your lifts usually. Usually you put it around here and it's connected to the axle. And it basically measures the amount of degrees that the lift is shifting so that you can program it to go a certain height.
Okay.
Anything else?
What are C-channel?
So a C-channel is basically this right here. It's just a piece of metal and it has a C like this. That's what it's called, C-channel. It's one of the most used parts in robotics and we use it to build most of the structures.
Pneumatics.
Okay, so pneumatics, you know how like air pressure systems work? You have an air tank and it packs air into it, right? So it's like pressurized air and then there's a piston on it.
Yeah.
And as it releases the air, the piston goes out and in like that. It goes like that. And you basically use that usually used for like pneumatic brakes where like it thrusts itself into the ground basically and it lifts your robot up on a sheet of metal so that nobody can push it over. Pneumatics in like lift design, maybe not so much for lifts, but you use it for other things like launchers, things like that where you're like hitting something with it. You don't use it that often, but we do have it in case we want to. That's something we should probably cover later. We'll cover it. Also, you can see there's rubber bands on that, and we'll talk about tensioning later. The first lift we have here is the basic chain bar, which is basically what we built right here. As you see, the end isn't built as efficiently as we could because we were running out of time. But basically what it does is you just have a motor here connected to a gear with the sprocket and chain here. And as this turns, since the gear is screwed onto this piece of the C-channel, the C-channel is going to move with the gear. So as the motor turns it goes up and down, It's like basic things. Out here we have our sprocket with our chain connected to the sprocket, and what this does is it just provides extra lift to it. So as this sprocket moves, this sprocket is screwed into the C-channel so it can't actually move. So the movement it puts on this one creates tension, which helps it lift up and down. So if you just lift this. As you can see, what I did here is I rubber banded this to have more tension to the entire system. Because usually, any way you put it, it's just going to fall because of gravity. But if you rubber band it properly, you can have it hold in certain positions. It's like holding fair instead of falling. So this is another thing that we do on lots of lifts to make sure they don't instantly fall after you lift them up. Is you rubber band them, and then you can use your motor to bring them down and up.
Stand.
So you can play the video for the basic one. We have rubber bands here, but what they have here is this really small gear, and the gear difference between this gear and this gear stops it from falling. Because the difference between this gear pushing on this gear creates a tension, which stops the actual entire thing from falling, which is, as you can see, I try to do with this gear on the bottom, but this gear, it's too big, so it just falls anyways. But actually, if you have this tiny gear here, this larger gear here, it'll prevent the tire lift from falling, so you can actually hold in a position like this. Because you see, if this gear can't move, this gear won't move either, so it won't fall. Due to gravity. Right, Deepak?
Yeah.
Wait, so does it push to the side? How does, with the small gear, how does the big gear?
Alright, so you have the motor is connected to the small gear. The motor is connected to the small gear, and as the small gear is turned by the motor, it's turning the big gear, which is turning the rest of it. And this small gear ratio to large gear ratio also adds a lot of power to this, so you can actually carry a lot more. And normally, if you're if you want to hold it in a set position, right, you stop the motor, and if the motor stops and there's no power being applied to it, it's going to fall because of gravity, right?
Yeah.
But as this gear starts falling, it's going to start pushing against this gear because they both have to move for it to move, right? But since this gear ratio is so small than this one, it takes a lot more power to turn this gear than for the big one. So it's enough tension to stop gravity from pulling it down.
Okay, I get it.
You guys understand that?
Yeah, I get it.
So the next lift we have is the scissor lift. Basically, let's show the video first. So as you can see in the video, one big disadvantage of scissor lifts is that the bigger you go, the less stable they become. As you can see here, they have to close it really slowly so it wouldn't tip over. That's why they're not used as often yet, but they're definitely a good one to learn. So basically, as you can see right there. So as you can see, basically a scissor lift, you have a pattern of two channels that are crossing like this, right? Yeah. So this is what you have. And the way this moves, the way it goes up and down, is based on the compression right here. So as these go away, the entire thing falls, right? So as you can see on the bottom here, they're rolling this way and that way and it's falling. And basically what we have for those, we have things called sliding tracks. They're like little green parts. How do you draw that? But
You
anyways.
know how the gear is set up? Like, you know how it has the teeth on the gear? It's like a straight gear.
Yeah, so it's basically
It's flat.
a part that's like this, and it's got gear teeth on it like this. Okay? And you have a gear at the bottom of the lift, on the bottom two channels right here. You have like a gear right here, and you have a gear right here, and it's rolling. See, it's got teeth or whatever. And it's rolling on the sliding track, and it's allowing you to roll this way and that way and put them together. So usually you have two motors turning these in opposite directions, so that they go together like that. And that's basically how it goes like that. But the problem is this, is like the maximum you can put on it is 4 motors. And since the motors are on the lift has to carry the weight of the motors itself and then more levers on top of that. And that's why scissor lifts aren't going to be as strong, because the more you put on it, the farther it's away from the actual power. Because as you can see here, since the motors are down here, right? And what's carrying is all the way up here. So the distance between the actual source of power and what it's carrying is so great that it's like almost obsolete. There's like no point to use it in a lot of situations because it just can't carry a lot of weight because of that design. Actually, 2 years ago, we got to states competitions and we tried to build a scissor lift like this. It took a lot of time, but we actually made one work pretty well. But once we started putting weight on it to carry, we realized it actually couldn't carry more than just a screw box. So you have to be really wary of that when you're building a scissor lift. Any questions on the scissor lift?
If they're so weak, why do you bother?
Because
the pros.
because it's easy to build, for one thing. It's a lot easier than most lifts to build. You can stack it up to go pretty high. If you build it in certain ways, it won't tilt as much. And if it's something that isn't a lot of weight, or you just have to go up and knock something down, then it's really easy to do.
Oh,
So next we have the 4-bar, which is kind of an iteration of a chain bar, but it's a lot more stable. And it's a lot more stable, a lot more practical for using in actual robotics competitions.
As you can see, like, this is really similar to the scissor lift in the fact that it can get really high, and the minimal amount of metal that is used makes it a little bit easier for the motors to push it up and bring it back down since it doesn't weigh as much. However, as you saw, when it reaches the top, it does shake a little bit, so the stability is an issue, as most higher lifts are. However,
Basically, the mechanic on this is of like a chain bar, where it has bars like this on the bottom here, which I'll pull it up, and then it's basically stacked on top of it, so it opens up when it goes higher. it allows cross channels to come between it, so there is a higher stability than most scissor lifts and other than that. But yeah, of course, when you get to the top, it's a little unstable. And, yeah.
Oh, are you speaking after you're thinking out a question?
Okay. So this is a common lift that also uses rubber banding tensions to help it open at the top. So as you can see, there's no motors on the other sides. So the only way it's going to open on the top is because of rubber band tensions. So you have to learn a lot about rubber banding. This is one of the more complicated types of lifts that requires a little bit more robotics knowledge to do. But it definitely is one of the better ones to use. And this is one of the ones that you see a lot of competitions throughout the years. The next one we have here is the reverse 4-bar, which is another iteration of the 4-bar. But basically what it's used for is that it's really compact and it can fit on one side of the robot really easily. And it's really good if you want to do something that's known as internal stacking, but it's really prevalent in the last 2 competitions and this competition. So basically what internal stacking means is usually it's done with the U-base. So you have I can explain this. You have your U-base here, right? Where you have that space in the middle here. And you've got some mechanism in here to collect what you're stacking, right? And then your lift is on the outside part here. And what it does is it collects things from outside here and here and puts it in this middle part. And your robot can drive around, but it stacks on it, is basically how it works. So you can show the video right there. So as you can see here, it has a very similar design to the normal 4-bar. And just on this one, the motors are going to be on the top here and here, and you've got more on the bottom right here, opening here, and you have all of these gears to lift the top part of that. The thing with this is you can only go to a certain height. It only has those 2 layers, and once you're there, it's done. It's not like scissor lift or later the elevator lift where you can keep stacking, so it has a maximum height and it's done. But it's really good. It's only these 2 parts. It's a really stable lift. It won't shake very much. You have a lot of ways to stabilize it even better afterwards, and it can carry a lot of weight pretty easily. Right here, this is one of the most complicated lifts. Guys, please pay attention. This is one of the most complicated lifts that we have in VEX, and it's called the elevator lift. Before you commit to building this lift, you have to really make sure you want this, because it takes a lot of time to build, and if it doesn't work in the end, it's going to be really rough on your team.
Yeah.
Sit out of experience. Basically what it does, it's really good, because it's a super compact lift that you can keep adding layers to get the height that you want. So it's really versatile in that way, and you can put in a really small part of your robot, so you can add a lot more other things to your robot. You can show this. So this is it just with the, I don't know. So as you can tell, if it works properly, the lift itself is really smooth and it can work really well. But as you can see, it is really complicated to do, and just this video itself doesn't do it justice. But if you look at teams that have actually solved this, they use a lot of their own parts in it. They don't use just the normal VEX stuff. There's a lot of editing that you have to do. You have to cut things down, make them in a certain way. You have to sand different parts down to make sure they fit right. It's a lot. You can't do it with just base VEX stuff. You have to do a lot of other changes to them to make it work for it. And it's a type of lift that you probably do in your last year when you're on a high VEX team. It's not something you want to be doing earlier on. We made that mistake and we spent months building an elevator lift that eventually didn't work out because we didn't know how to do it correctly. It was a good experience for us, but you have to make sure you know what you're doing when you're tackling these kind of builds. So can you go back? So yeah, it's a super vertical lift, so it doesn't take up much space. It can go as high as you really want it to go in VEX. It gets heavy really fast. It takes a lot of metal to build a lift like this. And a lot of the parts on it are, they only come in steel. So you can just use aluminum to make it lighter. It requires a lot of power, so you have to make sure you're using 2 to 3 motors at least on this lift, or else it won't work very well. And it is really hard to build, so not even the other logistical problems of it, just building it is a really difficult thing to do, unlike the other lift. So we wouldn't recommend this lift very often, but it does have certain situations where it's really good.
I've never seen a team use it.
Yeah, we
We
have.
did actually try using it last year. I can actually pull up our trailer from our team last year, and there is a little clip of us actually of like the actual elevator lift, a section of it. However, it does go really slowly. The power is really difficult to manage, and it is very heavy. So it's kind of like a toss-up to whether you want to use it or
Have
not.
you seen like a team like use
Yeah,
it
we
in
have.
competition?
We have, and it works really well. It's really smooth, but it's really hard to do. You have to have a lot of time in advance to build it. You have a lot of experience. Because when we did it, it took us forever, but we finally got it to work. But it ended up being too heavy on a robot as well, and it was just really slow.
Did you guys
No,
Well, we didn't use it on our. We ended up
we changed it to something else at the end. But yeah, for something like this, you have to make sure you have a lot of time before competition to get it done and to test it and have time to bail on it and do something else in case it doesn't work. Because this is something that you just can't expect to work 100% of the time. You have to be ready to bail on it, basically.
What did you guys go with after that?
So for our competition, we actually went with the basic chain bar, I think, after that, because we didn't have time. Yeah, it was like a chain bar. It was like this. Because we didn't have enough time.